Good afternoon, everyone. The theme of our today's report is modeling the process of soil erosion during amber mining. The authors of the research have been working on this topic for the last 3 years and are the following: Zinovii Malanchuk, Valerii Korniyenko, Oleksandr Vasylchuk, Vitalii Zaiets, Yevheniy Malanchuk, and Myroslava Kucheruk. The structure of our presentation is following: the main methods of amber extraction, modeling the process of hydraulic dewatering of amber-bearing rocks, results of the research, and the conclusions and acknowledgements. Significant reserves of valuable amber have been discovered in Ukraine. The Rivne region accounts for about 6% of the world's amber reserves. Currently, mining takes place in the north of the Rivne region. Amber is extracted from the sandy deposits using two main methods. Mechanical methods involve the mechanical development of quarries or massive underground soil massifs and include the following: opening of production soil layers, drilling, rock transportation, screening, rockation, and land reclamation. This method of amber extraction is carried out by a set of machines and is now outdated. The hydraulic method is carried out using high-pressure jets to erode productive soil layers and hydraulic flows to bring amber to the surface of the deposit. During developing a simulation model, the following tasks are solved. Changes in vertical, horizontal, and tangential loads on the particle are taken into account in accordance with the peculiarities of the kinematic structure of nature flows that cause erosion. Random values of particle diameters and roughness protrusion height are generated. From the complete system of differential equations describing the motion of particles, the time of detachment of each ball from a sufficiently large set of them is determined. On this slide, presented next schemes. In figure 1, we can see flow around a spherical particle in a turbulent flow. In figure 2, the effect of hydrodynamic pressure on the particle surface, and in figure 3, the tangential stress of the surface of a ball. On this slide presented fourth scheme on a particle in a turbulent flow. Utilizing the Lombard principle, which balances all forces, including inertia, action on a particle, the movement of a spherical particle, can be delineated by an using system of differential equations alongside the corresponding initial conditions. There are three positive variants of particle detachment. The first corresponds to the moment when the sum of the active vertical components of the forces exceeds the sum of the force of gravity and vertical component of friction. In this case, the breakaway condition can be written in the following form. The second option is the rotation of a particle around a point and its separation from the point of contact at the moment when the reaction becomes zero. And the third option is the rolling of the particle over the barrier and its further movement in the form of a swing. In this case, the separation condition stays the form. The block diagram of algorithm for determining the conditions for particle disruption during hydraulic dewatering of rocks in amber mining is shown in figure 5. Figure 6 shows a graph of the probability of particle disruption dependence on the dispersion of the bottom velocity. As can be seen, with an increase in the dispersion of the bottom velocity, the probability of disruption increases. And at the value of 0.05 to 0.1, the probability of disruption is close to 0.01. As a result, we can conclude that numerical calculations have shown that with an increase in degrees of soil heterogeneity, the probability of particle detachment increases. For example, a twofold increase in the standard deviation from the mean diameter from 1.2 to 1.4 mm at the particle diameter 1.4 mm resulted in a twofold probability of detachment, which is caused by the removal of small particles. As a result of the numerical experiment, an important fact was established. The nature of the particle removal significantly depends on their diameter. At 1.4 millimeter and smaller diameters, particle detachment without rolling or vertical fly prevails. At the large diameters, only rolling is observed. A similar pattern was observed in the experiment. The reliability and stability of the algorithm is also confirmed by comparison with the results of analytical solution of the problem. This work would not have been possible without the support and assistance in conducting the experiments provided by the National University of Photo-Environmental Engineering, Rector Viktor Mashinsky, and the KKNK Technobud. The research was carried out at the National University of Water and Environmental Engineering, which is located in city Rivne of Ukraine, and with the participation of specialists from the KKNK Technobud, which is located in Klesy village, Sarny district, Rivne region, Ukraine. Thank for your attention.